Dear students, welcome you all to the course that is Fabric Manufacturing Technology. In the last sessions, we have discussed about sizing machine. So in the sizing machine, specifically we have discussed about what are the objectives of sizing machine or sizing process, and we have discussed about two-cylinder sizing machine and multi-cylinder sizing machine, and what are the different types of size ingredients we are using, like primary ingredients and secondary ingredients, and what is the size paste preparation process, and what are the equipments involved in the size paste preparation process. So finally, in the sizing process, we have discussed what are the different faults which are going to be produced, and what are the causes and remedies for the particular fault, how to overcome that particular fault in the sizing process, so that we can going to maintain the proper weaving efficiency and proper working conditions in the further process. Here, today's session, we are going to discuss about the post sizing operations. Okay, so after sizing, post sizing, nothing but after sizing, what are the operations? Okay, so after sizing, the sized weaver's beam, so in the sizing machine we are going to produce sized weaver's beam. So the sized weaver's beam is going to be transferred or transported into the next department, that is called as post sizing operations area. So particularly these post sizing operations are drawing and denting. Because this beam, whatever the weaver's beam we are produced in the sizing, so this beam directly we cannot able to use in the weaving. Directly we cannot divide the warp sheet or warp sheet into the two layers. So we required some elements, we required some parts, so that we are going to divide the warp sheet into two layers in the weaving area. Okay, so that is why we have specifically drawing in and denting. These two processes are very, very important. And along with these two, we have another process, that is knotting process or tying process. Okay, so either we are going for the drawing in and denting, or we are going for the knotting process. Okay, so when we are going to select, when we are going for the drawing in and denting, and when we are going for the particularly knotting or tying process. Okay, so we will discuss these two, what is exactly and what are the main procedure of doing this is. Okay, so let us see that what is exactly the drawing in and denting is. So drawing in is nothing but it is a process, or the yarns or the warp threads entering from a new warp into the weaving elements of weaving machine. So newly drop wires, heddles and reed when starting up a new fabric style. Okay, so you just observe that what is the drawing process is, we are taking the warp thread from the warp beam or weaver's beam. Okay, and we are passing this warp thread through the drop wires, through the heel wires and through the reed. There are three major components or three major elements. One is drop wires, second one is heel wires, and the third one is called as reed dents. Okay, so let us see that what are their functions of individually. Like, so you can see here there is a warp beam. So for understanding, we have taken the one end from the warp beam. The end is going to be passed through the drop wires, droppers we can say, drop wires or droppers. So after drawing through the drop wires or droppers, drawing nothing but there is a like a metallic kind of simple metallic plate structure which is having a perforation. through this perforation we are going to pass the thread. Okay, so after drawing through the drop wire, we are going to pass the end into the heeled wire. Okay, after drawing through the heeled wire, we are going to pass the warp thread through the reed. Okay, so what is the function of this drop wire is? Drop wires are used to like in the warp stop motion. For example, if the beam is consisting of 10,000 number of ends, in between something is happened and one end is break. One end was break during the weaving process. So now how to identify, how to know that warp end is break out of 10,000 number of ends? So there is a mechanism that is called as warp stop motion. Whenever the warp end is break, that time the weaving machine is going to be stopped and it will give an indication that there is a warp break. So now these drop wires are used to identify or used to stop the machine whenever the warp end is break. Okay, and the second one, that is heeled wires. So why these heeled wires or heddles are going to be used is, we required to manufacture the fabric, we need to divide the warp sheet into two layers. We need to divide the warp sheet into two layers. So to divide the warp sheet into two layers, we are using that heeled wires and heeled frames. So the minimum requirement of number of heeled frames in the weaving process is 2. Minimum requirement of number of heeled frames is 2. 2 number of heeled frames are required. In one heeled frame there are number of heeled wires. Number of heeled wires. For example, if the beam is consisting of 5,000 number of ends, 5,000 number of ends. Now we have two heeled frames. So what is the two heeled frames are why required is, in each heeled frame we have total 2,500 number of heeled wires in one heeled frame. So 2,500 in one heeled frame, 2,500 heeled wires in the second heeled frame. Now this 5,000 number of warp threads are going to be passed or drawn in such a manner that odd number of warp threads are going to be drawn through the heel frame number 1. Even number of warp threads are going to be passed through the heel number 2. Okay. So generally this is for understanding I have given a plain woven fabric structure. Okay. The design of this thing is called as after the drawing like this, you will get the plain woven fabric structure. So the design of the fabric is plain. So if you have a designs like Adobe designs or a small motifs in the fabric, if you required, now the drawing in order and number of heel frames required in the particular weaving machine is going to be changed. For understanding, I have given that the minimum number of heel frames required in the weaving process to make a plain woven fabric is called as 2 number of heel frames are required. Okay. After drawing the warp threads through the heel frames or through the heel wires, we are going to pass the warp threads through the reed. Through the reed. Reed is nothing but like our comb. Like our comb. So there is a metallic frame which is having the reed dents. So there is a gap between the two dents. There is a gap between the two dents. In between these two dents, we are going to pass the warp threads. Why this reed is going to be used is, whenever the weaving process is happening, after the picking, after the weft yarn insertion, so the weft yarn has to be taken towards the fell of the cloth. After the picking, the weft thread has to be taken towards the fell of the cloth or beat up towards the fell of the cloth. So the reed is going to be used to beat the newly inserted weft yarn into the fell of the cloth. So these are the major parts, and drawing in nothing but, specifically drawing in nothing but, drawing of warp threads through the drop wires and the heel frames are called as drawing in process, and denting process nothing but drawing of warp thread after the drawing these whatever the warp threads are, drawn warp threads are there, we are going to again drawing through the reed dents. Reed dents, that is called as denting process. Reed dents. Through the dents of reed we are passing the yarn. So we are taking the yarns. So this process is called as the denting process. So this is the two-step process. Drawing can be done first time. Drawing can be done at the first stage, and the second step we are going to draw the threads. After drawing completion, the drawn threads are going to be again drawn through the reed. That is called as the denting process. Okay, so these are the major things what is exactly drawing in and denting is. Now you can observe that overall look of the weaving machine, where exactly we have the weaver's beams, and there are weaving elements in between that, and we have a fell of the cloth, and there is a fabric take up mechanism. So the individual driving mechanisms or individual servo motors are there for the weaver's beam as well as for the take up mechanism. So that is take up mechanism nothing but to take the formed cloth or prepared cloth in the weaving process. So take up nothing but the winding of the fabric or taking up of the fabric, fell of the cloth to the take up mechanism or to the cloth winding mechanism is called as the take up system. So this is the overall look of the weaving machine, and you can see that whatever the explanation I have given, there is a beam, and through the droppers and through the heeled wires we are passing the yarns. Then there is a reed. It is like a metallic frame and which is having the dents like our comb. Okay, so this process, total this two-step process, that is drawing in and denting process. Drawing in and denting process. Okay, so these are the two steps which are generally used for the new styles, for the new beam or new style. If we are started the first time we are starting the weaving process, so this two-step process has to be followed.
When a new denim style is put on a weaving machine, it's necessary to draw or insert the warp yarns through various loom elements. The flow of the yarn in the loom is easily seen from the illustration. The weaving process starts with the sized yarn coming off the loom beam in a single sheet or layer of yarn. The yarn then proceeds over a tension or whip roll that is designed to maintain a constant level of tension on the warp yarns throughout the entire weaving cycle. Each yarn then travels through its own drop wire that serve as stop-motion detectors. When yarn tension drops too low, or when the yarn breaks, the metal drop wire will complete an electrical circuit and the loom will stop. Next, each warp yarn then passes through its own heddle that is suspended in the harness. The heddle has an eye through which the yarn passes and allows for exact control of each yarn. The harnesses control the raising and lowering of the warp yarns. The yarns then proceed through the dents of the reed. The reed is a comb-like device that maintains the spacing of the warp yarns, controls the width during weaving, and performs the beating up of the filling yarn into the body of the cloth. The point where the yarn is beaten up into the cloth is called the fell of the cloth. This is the transition point where the yarn becomes fabric. The cloth now winds over the take-up roll, sometimes called the sand roll or press roll, which, when combined with the let-off of the loom beam, controls the number of picks per inch in the fabric. Finally, the cloth is rolled onto a cloth roll. The threading or drawing in of the yarns can be done manually or automatically on drawing-in machines. Of course, manual drawing in is much more time-consuming. When the same end count and draw is to follow on a loom with a depleted warp, then a full beam of yarn can be tied to the yarns of the old beam. This can be done by the use of a tying-in machine, which automatically selects an end of yarn from the old beam and ties it to the appropriate end on the new beam. This can be done very quickly with minimum loom downtime.
Now you can see that how these warp ends are going to be drawn through the drop wires and heel wires and the reeds. you can observe this image. There are two men who are working in the particular operation, that is drawing in and denting operation. You can observe that one man is finding out the threads from the warp beam. So the man one is finding out the warp ends from the warp beam.
After sizing, warp yarns need to be threaded through droppers. Heeled wires are the heeled frames and the dents are the reed of a weaving machine before weaving can start. Each warp end should be drawn through one dropper. The operator draws the warp ends through heeled wires of the harness frames and dents of the reed in sequence according to the drawing-in plan. If the new warp is going to produce the same fabric woven on the loom, the new warp ends can be knotted with the existing warp ends by a tying machine. Then the new warps are being drawn through the droppers, heeled wires and the reed to start weaving.
So the second person who is going to use an element called as drawing pin. So the drawing pin is going to be inserted through the hole of heeled wire and the drop wire. Through the hole of heeled wire and the drop wire. So drawing pin is going to be inserted through that, and the first man who has already selected the warp thread is going to be wrapped around this drawing pin, and the second man is going to draw through the drop wire and the drop wire and the heeled wire. Through these two parts, the second person is going to be drawn the warp thread through these two parts. So after the completion of drawing process, the denting can be done. Now you can observe here the same image where the man one is selecting the warp threads. There is a beam at the back side and he is selecting the warp threads one by one, and the second person who is going to use the drawing pin to draw the warp threads through the drop wires and the heeled wires. So he is feeding, the first man is feeding and second man is drawing through these two parts. And you can observe that how the warp thread was holded by the drawing pin and how this drawing pin was inserted through the reed and through the heeled frame and heeled wire and through the drop wire. You can observe that there is a drop wire and there is a heeled wire and there is a reed. Okay, there are three parts. You can observe that the drop wire, through the drop wire and through the heeled wire and through the reed at a time, all three together. So the man 2 is inserting the drawing pin and he is taking the warp thread through this. Okay, so this total process it is. So drawing can be done like this, and as I told earlier, like the minimum number of heeled frames required for weaving is 2. So here, to get the plain woven fabric structure, we required 2 heeled frames, and as I earlier told that, so the all odd number of ends are going to be drawn through the heeled frame number 1 and all even number of ends are going to be drawn through the heeled frame number 2. Okay, so that whenever the heeled frame 1 is raised, all odd number of ends are going to be raised up and even number of ends is still in the bottom side, so that the shed formation can be occur. So shed formation nothing but the dividing the warp sheet into 2 layers. So the warp sheet is like this and it is dividing like into a shed. So this dividing the warp sheet into 2 layers is called as the shedding process, and the shedding process will be going to done with the help of heeled frames we are using in the weaving area. So directly after drawing in and denting completion, so along with the heeled frames and the reed, along with the beam, all these 3 is going to be transported into the weaving machine and it is going to be kept on the weaving machine for the weaving process to manufacture the cloth. Okay, so these are the some of the parts, like how the drop wires are looks and how the heeled frames are or heeled wires are going to be look. And there are like if you have a manual drawing process, it is going to be taken like so much of time consuming process. It is like a time consuming process. So it is like again there are so many factors which are going to be affect the drawing in process and denting process. So particularly like for example, if the beam is having more number of ends, obviously you need to draw the all number of ends. The time required to draw all the number of ends are going to be more. Okay. So if the count of yarn, that is fineness of yarn, is very finer yarns, so in that case, to identify the threads and to draw the threads into the drawing in and denting is taking much more time for the drawing in process. So there are so many factors. So one of the factor like the manpower or man, so the skilled man can do within the time, but in an average, for example, if the beam is consisting of 7,000 number of ends, so with a simple design construction, so it is going to be taken like 8 hours of time to draw all 7,000 number of ends. So 2 men is going to be work. So each man we are paying the wages. Say for example approximately 300-400 rupees, 400 rupees per man. So 2 men who are working in the area. So 400, 800 rupees we are giving for drawing of 7,000 number of ends. So it is like a very costly and very costly also. Sometimes if it is costly it is okay, but what is happening is it is taking too much of time. So till the completion of drawing in process, so sometimes the weaving machine has to be idle. So that is why we have a simple and we have a modified and automation has been done in the drawing in and denting process. That is, we have a sophisticated machinery, that is automatic drawing in machine. Automatic drawing in machine. So automatic nothing but, you can understand that without manpower nothing but with one man we can do the drawing in within the very less time. Like for example, if the manual drawing in process it is taking 8 hours of time, and you can understand that by using the automatic drawing in machine, the same number of ends and same count with the same drawing in process. So in the automatic drawing in machine you can complete within 1 hour time. So 8 hours manual time and automatic drawing in time is 1 hour or 1.5 hours. So now you can see that what is the thing which is directly there in the manual process as well as the automatic process. But there are some advantages and disadvantages even in the automatic drawing in process also. So we will discuss in the further slides. Now you can see here, this is the complete picture of automatic drawing in machine, where generally it is a sophisticated machine. You can feed the warp beam and you can feed the heel wires into the machine. Directly what it will do is, it can find the warp threads from the beam and it can find the heel wires and drop wires from the magazine where you have kept the drop wires and the heel wires. So it is going to be identify and it is going to be select, and drawing can be done automatically by using the drawing pin. So automatically the warp thread is going to be drawn through the drop wire and through the heel wires. So it is like a computer operated. You can see that how many number of threads are completed, how many number of threads are still present. So what is the speed of working? Nothing but how many warp threads are it is drawing per 1 minute of time. So how much time it is taking to complete all the number of ends to drawn. Okay. So what is the quality which is running presently? So all the things, all the data can be stored in this system. Okay. So along with that, so it is like a costly also, but one time cost effective. So if you spend 1 crore rupee for this, and you can use a prolonged time. Okay. So and you can get the accurate drawing in process without any errors in the drawing in step. Okay. So this is the sophisticated machine which is generally used. So there are different types of automatic drawing in machines. Okay. But the major function is to draw the warp threads through the drop wires and the heeled wires. Okay, this is the thing. Okay, and after the drawing in process, the denting will be done manually only. The denting will be done manually only. The denting nothing but after completion of drawing in process, the drawn warp threads are again we are going to take through the reed dents. Okay, so 1 per dent, 2 per dent, 3 per dent, it is going to be decided, so it is going to be selected as per the design availability or design we are going to manufacture in the weaving process. Okay, so this is how after completion of the drawing in and denting process, how the beam along with the heel frames and reed is going to be transported, and what is the transportation equipment we are using for the carrying of beam, heel frames and the reed to the weaving area. Okay, and you can see that there are features of automatic drawing in machine, where I have given that for the comparison, like 3 different models of automatic drawing in machines and their particulars or technical features are given here, and you can observe that there are 3 models like a Delta 100 by 110, Safari S80, Safari S30. There are 3 different models I have given, and you can observe that mainly drawing in speed ends per 1 minute. How many ends per 1 minute it is drawing in Delta machine? It is 100 to 140, and you can see that Safari S80 approximately it is drawing 160. So the technical specifications as per the machine manufacturers, it is given that so up to 160 number of ends can be drawn per 1 minute of time. Okay, per 1 minute of time. You can assume that if the beam is having 10,000 number of ends and per 1 minute it is drawing 100 number of ends, and you can observe that, or you can find out that 1000 number of ends how many minutes? 10 minutes. 6000 minutes? 60 minutes, 1 hour time. 7000 minutes? 70 minutes. So 1 hour, 10 minutes of time. So directly you can calculate how much time it is going to be taken for the drawing in process. Okay, and you can observe that the Safari 200 ends per 1 minute, and you can see that how many number of warp beams can be kept 1. Okay, and how many maximum number of heel frames can be mount or can be produced in the used in the automatic drawing in machine. You can see that 20, 28, and there is no limit to the S30 case. Okay, so like that there are technical features. What is the count range, what are the hook type, what is the beams, what are the number of beams can be used, how many number of heel frames can be utilized in the automatic drawing in machine or can be used in the maximum, how many number of heel frames can be used in the automatic drawing in machine. These are the some technical specifications. We'll see one small video on the automatic drawing in process now. as I earlier told that the drawing in denting process is going to be done for the new quality or a new style. So particularly, for example, if the beam is started now, if we are starting the new style of fabric in the weaving process, then in that case we are going for the drawing in and denting process. Okay. For example, if the fabric is having too much complicated structure or too many colors of warp threads we are using, like 7 different colors or 10 different colors we are using. So in that case also we are going to select specifically drawing in and denting process. Now what is this knotting process is? Knotting nothing but already there is a beam which is running in the weaving process or weaving machine. Now it is going to be exhausted. Now within 1 hour of time or 2 hour of time it is going to be exhausted. So the same fabric, same quality of fabric, we need to produce one more beam, nothing but 10,000 meters already we have produced. One more 10,000 meters of fabric we need to produce. In that case, what we are generally doing is, we are preparing the sized weaver's beam, and the sized weaver's beam directly we are going to send into the particular weaving machine, and already running warp it is there in the weaving machine and new warp sheet is there in the beam. So the ends from the warp, old warp in the weaving machine, and the new warp from the warp beam, new warp beam is going to be tied, one end by one end we are going to tie, we are going to knot. Okay. So for example, 10,000 number of ends are there in the old beam, and the new beam also should have 10,000 number of ends. Now end to end number 1, both together we are going to knot. End number 2 we are going to knot. End number 3 we are knotting. So like that, all 10,000 number of ends are going to be knot individually by using a knotting machine. There is a machine called as knotting machine or tying machine, where this machine particularly will be going to do the knotting process completely. So the beam is going to be mounted in the weaving machine, and the old warp is going to be taken together, brushing can be done, then both the ends are going to be selected by this knotting equipment, then knotting can be done. So this process we will see a small video, okay, so that you can understand better. So before that, you can observe that there is an image, and where the old warp and the new warp together, she is knotting with the help of some mechanism, that is knotting machine. Okay, so tying is used when the fabric is being mass produced, that is same production, 10,000 meters, again we need to produce one more 10,000 meters. In that case, mass production means that is tail ends of the warp from the exhausted weaver's beam is tied to the beginning of the new warp beam. Okay, so as I already explained, therefore if every end one on the new beam is tied to the corresponding end of old beam, the drawing in process can be omitted. So there are following the tying process, all you can see here. So there are different stages: taking out the loom, the prepared beam with the harness, transport the beam into the weaving area, fastening the heel frames, both the heel frames of the weaving machine is going to be tied so that it is going to be proper. After that, the warp sheet of the old warp beam and the new warp beam, old warp and the new warp is going to be combed out, then knotting can be done. So after that, the passing of knots by the proper drawing in and warp piecing up can be done, then you can produce the fabric. So these are the different steps. So these steps we will see in a small video so that you can understand. Okay. Now, as you have seen that video, so you can understand that what is exactly the knotting process is. And you can see here the main benefits of warp tying is, so more efficient, flexibility and quality. So efficient nothing but in terms of the production, in terms of the time consuming process. Now if you want to go for the drawing in process again, it is going to take 8 hours of time again. So that is why we are going for the knotting process. So drawing in and denting process is going to be eliminated. So this knotting process can be done very easily and within the less time. So as I told in the automatic drawing in process, like number of ends which are going to be drawn per 1 minute is like 160 and 200 number of ends. Similarly, you can see here the speed of the knotting machines are like very high, like 200 sometimes. So we will see that you can observe here the VHS of this is like 600 knots per 1 minute. 600 knots per 1 minute. So nothing but 1 minute 600 ends are knotting. Okay. And you can go for the vast varieties of yarn types or fiber types and counts. Okay. Multi-filament or any kind of filaments or yarns can be produced. That is depends upon the type of manufacturer or type of the equipment we have. So approximately, for example, if you take 500 number of ends per 1 minute, it is knotting. So if the beam is consisting of 10,000 number of ends, so how many minutes it is going to take? 500. So 1000 it is taking 2 minutes. 10,000 it is taking 20 minutes. Approximately completion of all the knotting process, it is going to take hardly 40 minutes to 1 hour maximum. Okay. So it is very economic and efficient. Okay. So that is why if the ordered quantity or if the fabric mass production it is there, in that case we are going to select the knotting process for the knotting and to the completion of drawing in and denting. So instead of drawing in and denting, we are going to select if the quality of the warp beam is same as it is running in the weaving and the new beam is produced in the sizing, both are same. In that case we are going to select the knotting process. If it is different quality, multicolor, sophisticated design, complicated design, in that case we are going for the drawing in and denting process. Okay, so this is all about the knotting. So particularly this session we have discussed about drawing in and denting process and knotting process. Whenever the qualities of running quality and the new quality beam or beam of new beam which is produced in the sizing machine is same, in that case we are going for the selection of knotting process to complete this drawing in and denting. So this is all about the post sizing operations. So thanks for listening. Bye.